Hello. Hello, good morning everyone. Magandang umaga sa inyong lahat and welcome to our stream for today. We're going to have our discussion. Hindi pala to F2F. Ngayon ko lang napansin guys na yung PowerPoint ko. Hindi siya F2F online. Alright. Okay. Baka kalain nyo na F2F discussion to, no? Online to online. Okay? So, we'll be covering the questions that were provided to you last Friday, Saturday ata, no? The online module. Ayan. So, i-discuss natin yung mga questions there on structural engineering. That's from number 37 to 66 of your online module last week. Okay? And for those of you guys who have attended our face-to-face discussion, you will find the questions familiar because these were also discussed sa face-to-face. Okay? Alright. So for those of you who have attended our face-to-face classes, of course, this will be another set of problems for you to practice and see if talaga bang may natutunan kayo sa face-to-face discussion natin, no? Okay? So that will give you a chance to evaluate yourself and to evaluate your understanding and comprehension of the topics that were discussed. Okay? And same as before, we will be having our Padlet link there in the description. So, pwede din kayong, instead of clicking on the link, you can just log into Padlet. And in your Padlet dashboard, you could look for Refresher Week 3 PSAD Engineer Kanay. Okay? And by clicking that Padlet, you can join. No, you can now join the Padlet, and you can post your questions or anything that you would like to share with me or to the class as well. So you can interact with our discussion. Of course, meron tayong comment section dyan, no? Marami-rami na yung paramdam ng kanilang presensya, no? Dyan sa comment section. Whether greetings, good morning sa inyong lahat, no? Sa Padlet natin, we already have one who have posted, no? Henry. So, ayan. You can use your Padlet as well. Okay? Sige. So, okay lang ba yung audio ko, no? And my video? Audio and video check, guys, no? If it's okay, then we could proceed with our questions. Once again, this is from number 37 to 66. And we'll be looking at the stats as well, no? As we go through our solutions. All right, let's now have it here. So yung question natin dito is an 18 mm thick A36 plate, no? Number 37, guys. Is lap spliced with another plate using 10 28 mm diameter bolts with an allowable bolt shear stress of 450 megapascal. The plate is 200 mm wide and carries the load P. The diameter of the bolt hole is considered as 32 mm. Determine the bearing capacity of the connection if the allowable bearing stress on the plate is 1.2 FU. Alright? So this is our first problem. So ito yung given, no? TP equals 18, diameter of the bolt is 28 mm. N equals 10, that's the number of bolts. FU is 400 megapascal, ito yun, that's the property of the plate. So our allowable bearing stress for the plate is 1.2 FU. So we have it here. 1.2 FU, 1.2 times 400, that's 480. Okay? And our formula to get the capacity of the connection is load P is equal to the thickness of the plate times the diameter of the bolt times the number of bolts na times the allowable bearing stress on the plate. So, 18, tingnan natin. 18 mm, diameter of the bolt, that's 28. And our number of bolts, that's 10 bolts, times our FP na 480 megapascal. Alright? And that will give us our answer here na 2419200 newtons. Sige. Tingnan natin yung stats natin for this question, guys, no? Okay. We'll go over and look for number 37 in the question statistics that we have here. Ayan. 76.57%. That's good, no? Okay. Ito yung tamang sagot. Letter A. So that's good, no? Na marami na yung nakakuha nito. Actually, yung stats natin dito for the online module, if you're going to consider structural, talaga namang nag-improve, no? Talaga naman nag-improve. Kasi pag i-compare natin siya with what we had for this same set of questions, although iba yung given, no? So, face-to-face exam, same questions, iba yung given doon. Napakababa ng stats when we had that discussion. So, when we had that first exam for the face-to-face students. Okay? So, napakababa talaga. Like 40, there's only one or two questions na may 60% above, no? For this same set of questions. Okay? So, ayan. With the practice talaga, and of course, repetition, no? We could definitely improve our outcomes or our performance now, as what we can see here with our statistics. Okay? So that's good to know, guys, no? That's good to know. Number 38. So that's our answer there, 2419.2 kilonewtons. Okay. One moment, guys. Let me make some changes here. All right. Okay. So let's now consider number 38. So, ito naman yung atong comment dire. Okay. Determine the balance steel ratio of a beam with beta equals 0.835, no? FC is equal to 30.5 and Fy equals 415 megapascal. All right, so this is our given. Beta 0.835, FC is 30.5 megapascal and Fy is 415. Okay? So our formula for raw balance is 0.85 FC beta 600 over Fy times 600 plus Fy. Okay? So the answer there is 0.031 once you substitute everything. Substitute na lang yung given, ha? Substitute lang natin yung given. So the answer is 0.031. Okay? So, wala tayong issue dyan. That's pretty straightforward, no? So I'm hoping that the stats would also show the same. Tingnan natin. Number 38, we have 77.49%. Wow. So that's a really good outcome for the stats as well. Although partial stats pa lang ito, guys, no? As what Engineer Diego Gilisania informed us. Bale, kailangan na kasi naming mag-prepare for the class for today. So, yung partial stats ng online exam were given ahead, no? Para ma-assess namin yung statistics. Okay? Ayan, dito sa comment section may nagtatanong, ano daw ma-advise na 2 tapos 4:30 AM no nagising. Ayan, 2.5 hours lang yung tulog, no? Okay. Wow, napakasipag ng ano nyo, kaklase nyo. It's actually depending talaga sa effort, no? Yes, depending on the effort. And of course, pag alam natin na medyo behind tayo for a certain subject, it would be up to us to make adjustments and be able to spend more time, no? On the problems or problem solving or practicing. So, nasa inyo na yan, no? Although, one word of caution din naman for those who choose to to spend their sleeping hours as study hours, no? I think we should not do it every day din naman. So perhaps you could do that for some other days, but not all the days, not every day, no? Kasi ma-sacrifice din yung rest, which is very important for you. Kasi pag magkasakit tayo during the time of the review, and especially approaching the board exams, no? So yung trade-off niyan, you spend more time studying pero nagkasakit ka naman. So that would be something that um we wouldn't like to happen to us, no? Especially approaching na ang board exams. Okay? So ano din, be mindful of our health, no? Pero yung mga times na ganyan, talagang uh, there are really times na mag-pull out ta or ma-overtime ta with our study, no? But be sure to also set aside time. As a set aside time. Siguro hindi lang everyday na ganun. No? Okay? Ay, nagtatanong kasi dito. No? Kasi yung time ko when I was preparing for the board exam, well, hanggang ano lang talaga ako. I'm something of a morning person, no? So I sleep early. And not really early, 11 in the evening, no? And and I wake up around 6 in the morning. So, yeah. So, I think that's enough sleep din naman. No? And my review was in the mid-morning na, no? Sa mga 10 to 2. So that was my schedule during my review. Okay? Alright, so proceed tayo, no? Dito tayo sa number 39. A solid shaft with G equals 76 gigapascal has a torsional shearing stress of 42 megapascal, no? So we're going to determine the polar moment of inertia in mm to the fourth if the applied torque is 12 kilonewton meter. So, ano yan? Polar moment of inertia, no? Okay, so polar moment of inertia. These are our given, guys. May adjustments tayo dito sa the way this is solved. For those of you who have attended face-to-face, no? Please take note of the adjustment that we made here. Okay, so this is the formula that you see here is from the base formula natin sa torsional shearing stress, no? So the base formula for torsional shearing stress was TR over J. Okay, so once again, please take note of the adjustment that we made here. Although, if you're going to follow that solution that we had during the face-to-face exam, that would be the way in order to get a value that could be found in the choices. No? However, please take note of what we just did here. No? So, sa solution natin dito, our radius is actually in terms of the diameter. So, that's what we have here. So, T is equal to 0.5 D over pi over 32 D to the fourth. No? So, if you notice this one, pag i-simplify natin yan, ito, this would actually bring you to the torsional shearing stress formula for solid circular shafts. So that was 16T over pi d cubed. Okay? Yan. It's actually 16T over pi d cubed. Alright? Now, if you're going to do that here, okay, substitute the value for the torque, for the shear stress, no, as well. So you could solve for the diameter. You could solve for the diameter. And this diameter is 113.32, which could then be used to solve for the polar moment of inertia, pi over 32 d to the 4th. And that would give us 1619 times 10 to the 7, or letter B sa choices natin. Okay? So, ayan, no? I hope that made sense to you. No? So, yung kaibahan lang dito sa face-to-face, parang nagiging constant yung ano natin doon, no? Radius. Hindi na siya dependent sa diameter. So, this is a more accurate way to solve the problem. A more accurate way to solve the problem. So, kasi yung radius natin doon, radius natin dito, should be dependent on the diameter. And as well as the polar moment of inertia, which is the unknown value dito sa problem natin. Alright? So, ayan, no? The solution here shows we have J equals Letter B, 1618835. Now, take note of the formula for the polar moment of inertia, no? Pi over 32d to the fourth. Okay? Ayan, polar moment of inertia yan, ha? Yung statical moment of inertia, that's the pi over 64d to the fourth. Pero for polar moment of inertia, that's pi over 32d to the fourth. What do our stats show here, no? Number 39 tayo. So, ito yun siya. That is 47.97% yung ano dito, nakakuha ng correct answer. Okay? 47.97%. Alright. Sige, so let's have the next one. Wala kayong tanong dito, guys? No questions on this particular question? Dali, no? Okay. So, review lang din natin, no? Marami pang formulas actually that are related to the topic of torsion in strength of materials. So, TR over J, well, of course, that's the general formula for shearing stress. And this is the solid circular shaft formula. Meron din tayong formula for the, ano yun, angle of rotation, no? Angle of twist, yung TL over JG. We also have a formula for shearing stress for hollow circular sections pag meron tayong outside tsaka inside diameter, no? So it would be better as well, no? I would highly encourage that you review those formulas, no? Para sa strength of materials, especially dealing with torsion and as well as with all other subjects na naman. Okay? Sige. Next question tayo. Determine the plastic section modulus in mm³ of a rectangular section 200 mm by 500 mm. So, ito yung given natin, B and H, and the formula for our plastic section modulus of a rectangular section is BH squared over 4, no? So, if we substitute the value there, 200 times 500 squared over 4, that will give us 125. Ano to? 12.5 million ba yan, no? 12.5 times 10 to the 6 mm³. Okay? And our stats here show that number 40, 75.28%, no? 75.28% got the correct answer. Okay? Ayan. So, just to recall, although hindi ko na pakita dito, no? Just to recall, what is the derivation nga, no? Paano nga na-derive yung BH squared over 4? Let me just write it over here. Paano na-derive yung BH squared over 4? So, ito yung ating cross-section dyan, no? Alright, so this is our width, and this is our total depth na H. Ito yung tinatawag natin na plastic neutral axis. Okay? Plastic neutral axis. Now, ano yung significance ng plastic neutral axis? The plastic neutral axis divides our section into two equal areas. Two equal areas. So, iba siya sa elastic, no? Elastic neutral axis. Yung elastic neutral axis, that's where, saan nga yan makikita natin? Elastic neutral axis, nasa bending stress yan, no? Bending stress of sections. For example, meron kang bending stress na ganito. Yung elastic neutral axis corresponds to stress, bending stress equals 0. Mo yun siya elastic. Okay? Elastic na siya. Okay? While for the plastic neutral axis, the main principle there is that it divides this area into two equal areas. Alright? Yan. Now, how do we solve for our our plastic section modulus? The plastic section modulus is the summation of the statical moments of area, no? For both the compression and tension sides of our section. No? Kasi, yung stress distribution kasi nito, hindi na ganito. Kasi ito, this is elastic. Yung stress distribution natin, guys, no? When you talk about plastic analysis, would be like this. So, yung taas, either compression or tension, and the other side would be the opposite stress. Okay? So, pag compression ito, tension dun sa kabila. Okay? So, yung mga areas natin that is above the plastic neutral axis would be in compression, and the one at the bottom would be in tension. Just for this example lang ha. Just for this example. So, our solution would now be, kung gusto natin makuha yung formula, no, for the plastic section modulus, this is B, this is H over 2, this is H over 2. So that will now be area. So that would be B times H over 2. Now, what is this Y distance? Remember, this is statical moment of area. So, moment siya ng area. That means, kailangan natin ng moment arm. So, ano yung moment arm dito? That would be from the centroid of the area towards the plastic neutral axis. That would be H over 4. Okay? H over 4 siya. So, multiply ko siya dito by H over 4. Ito yung moment arm. No? Moment arm ng area na yan, na nasa taas. Okay? Now, for the tension side, same thing. Meron tayong centroid. Distance towards the plastic neutral axis, I will have this as H over 4 as well. So, bali, yung ating area sa baba is still the same, B times H over 2. Yung ating distance is H over 4. So, pwede na natin tong i-times 2 na lang, no? Kasi yung area sa taas tsaka area sa baba and their corresponding moment arms are the same. Okay? So, when you simplify this one, this will cancel out, and our formula would now be BH squared over 4. Okay? So, yun yung ating plastic section modulus, no? Formula na. Alright? So, hello sa ating mga 256 viewers or 257 viewers ngayon sa Facebook, no? Magandang umaga sa inyong lahat and welcome to our class. Okay. But anyway, no, when we talk about formulas din naman, for this particular problem, parang alam natin siya. Kasi 75% got that correctly. Okay? So that's good. That's good, guys. Oh, good morning. Good morning. Julius and Jimwell. Ayan. Okay. So, practice ta kadali, no? Practice ta gamay, guys. For our next slide, practice tayo nito. Practice. Okay? Practice, guys. Compute ZX. Ito yung ating i-compute dyan, ha? ZX. Compute for the plastic section modulus with respect or along, no? With respect to the x-axis, ZX. Sige, based on the principle that we just discussed. Principle is summation AY. Summation AY, no? For both tension and compression areas, I would like you to spend a few minutes, no? And try to compute. Use your calculators there to compute for the value of ZX. And then after that, I will show you the solution as well here on our slide. Sige. Kaya magsulat ko sa solution dire sa MathCAD, guys, ha? You can try it on your own first. And please let me know kung ano yung nakuha ang sagot ninyo. Okay? Right. Okay. Ayan. We have answers here. Jefferson in Padlet answered 652,500. Tapos JC Kent din, no? Dito sa chat natin. Ayan, 652,500. How about the others? Do you get the same answer? So, I just finished computing it dito sa MathCAD, no? And verify that that is the correct. Okay, that is the correct answer. 652,500 mmQ. Alright? Musta man ang uban diha? Kuha ba? Practice na, no? Practice. Okay? Practice lang. Please apply the principle or the concept that was just introduced for ZX. Alright. Kung hindi nyo nakuha, no problem at all, no? Huwag mag-alala kasi ipapakita natin dito yung sa ating solution for the problem. Okay? Sige. So, I will now show you the solution to this problem, guys. Now, okay. Medyo maliit lang yung font dito. So, let me just adjust. So, gawin kong 150. Ayan. Okay. Sige. So, basically, yung first step talaga natin, okay, our first step is to locate the plastic neutral axis. Locate the plastic neutral axis, also known as the PNA. Now, i-locate nato siya ang location or locate the plastic neutral axis PNA. Okay? So, ano yung principle when we say plastic neutral axis? It divides our section into two equal areas. Ano ba yung total area ng section na to? Ito yon. Ito yung total area. So, that is the area of the top flange. So, that's 200 by 200. Tapos yung area ng web part, no? 20 by 250. So, yung total area natin is 9,000 mm squared. Okay? If you're going to calculate that. Okay? Now, ilocate natin yung position ng plastic neutral axis. There are two possibilities that we have to determine or we have to consider. Yung unang possibility, guys, is for the neutral axis to be located within the flange. Posible na siya, no? Posible na siya. Dire siya dapita, no? Mana i-verify ni siya or we have to determine. Okay? And the second possibility is for the neutral axis to be located within the web area. Ano siya? Now, pwede na siya, no? So, we have to determine that. And for us to do so, ganito yung gawin natin. isolve muna natin yung total area ng flange. Bale dito sa taas. Ano ba yung total area ng flange part? Ito. No? So the total area of the flange part is, excuse me. Okay. 4,000 mm squared. So that's 200 by 20 mm. Ano ba yung half area ng total? No? The half area of the total is, ilan ba siya? 4,500. Okay? 4,500. So this means that the area of the flange is not enough, no? Kulang siya to attain the half area requirement, which is 4,500. Okay? So, because the area of the flange is less than the half area, the PNA sorry. The plastic neutral axis is located below the flange. Or, in other words, kung below siya sa flange, this means within the web area. Okay? Ana siya, no? So, let's now determine what would that distance be. Ito, yung y distance natin papuntang plastic neutral axis. Ayan. So, let's call this distance y. No? So, this is now our plastic neutral axis we have determined by calculations na nasa web area siya. Okay? So, to determine that, we're going to get the remaining area required para maabot niya yung kalahati na requirement. No? So, that would be the total area, remaining area that would be required is the half area minus area of the flange. So, that would be mm squared din ito, no? Ano yan? 45 minus 400, no? So, A remaining is equal to 45 mm squared minus 4,000 mm squared. Yan. And, since nasa web area na tayo, yung thickness natin dyan is 20. Okay? So, yung y natin is A remaining divided by the thickness na 20. Okay? Sige. So, that is 500 mm squared divided by 20 mm. So, that would be 25 mm. Okay? So, ang kaning location na to, this is actually 25 mm. 25 mm siya. 25 mm below the flange. 25 mm below the flange. Okay? So, if you're going to determine this length over here down below, kani siya. So, this is 250 minus 25. So, this is now 225 mm. Ayan. Okay na. So, let's now determine na natin yung z natin, no? So, yung z natin dito, ano nga yung z? Zx is equal to the statical moment of area sa lahat ng areas na nasa taas. Okay? So, ito, tawagin natin tong area 1. Tapos ito, gawin ko lang yung color niya. I'll make this green. Ito, tawagin kong area 2. No? Tapos yung lahat ng area dito sa baba, I will call this area 3. Alright? Yan. So, iba't iba sila ng area, no? So, compression tong nasa baba, or I think it's tension, no? Hindi natin alam kasi wala tayong actual loading. So, ito area 2, ito area 3. They have their corresponding y distance as well, no? So, dapat makuha natin yung tamang y1 ito. For this centered as well, patungong neutral axis, meron din tayong y2. And for this centered as well, papuntang neutral, plastic neutral axis, meron tayong y3. Okay? So that would be our procedure. So sa Zx natin, let's consider the top flange first, no? 200 mm times 20 mm times, ano ba yung location natin na y1? So that is y, which is 25 mm plus kalahati ng ating thickness of the flange. Ayan. Okay? And then plus, dito tayo sa area 2. So that is 25 mm times 20 mm times 25 mm divided by 2. Alright? And lastly, para sa area 3 natin, so that would be 225 mm times 20 mm times 225 mm divided by 2. Alright. So, Zx would be 6.652 mm cube, no? So, this is now 652,500 mm cube. Okay? Ayan. So, that's good that we have may mga students tayo na, of course, alam na ng topic na to, no? So, ito yung y1 natin. Ito yung y2. Hindi na lang natin nilagyan ng variable, no? And this is our y3. So, I hope that's clear. Okay? Pagkuha sa y. Okay, pagkuha sa y. y1 is ato guning tarungon gud kimurag kuan man ni gayagaw nila, no? Okay. Yung y natin dito, yung y1 ba? Yung y mismo pala, no? Sorry ha. Yan siya ba? Kaning y din na 25 mm ito, di ba? Okay. Pakiulit ang pagkuha sa y. Okay, so sa y gid siya mismo. Alright. So sa y, okay. So ganito siya, no? That is by locating the position of our neutral axis. No? So yung total area natin, area ng flange, tsaka area ng web, 9,000. No? Okay. Yung area ng flange itself, or flange alone, 200 by times 20, 4,000 mm. Okay? Now, para malocate natin yung plastic neutral axis, no? We have to set it at the location that would divide our total area into two equal parts, two equal areas. Not necessarily the same shape, basta two equal areas. So, yung area ng nasa taas niya is equal to the area below it. Okay? So, mo ni siya. Ang atong half area, the half area is 9,000 divided by 2, so 4,500. Okay? Now, take note, yung flange natin, 4,000 lang yan. So, kulang yung area ng flange. Sa kailangan, kukuha pa tayo ng part of the web para makumpleto siya. Para makuha natin yung buong half area sa upper part ng section. Okay? So, kailangan, how much area do we need here para makompleto natin yung kalahati? So, ito yung ginamit ko. Parang ano lang ba? 4,500 minus 4,000. So, yung half area natin na kailangan ma-achieve minus the area ng flange na 4,000. So, kailangan kukuha tayo ng 500 square mm dito sa baba. No? Now, the area that we need to get there, area remaining, is equal to the y distance that we would want to solve times the thickness of that web area at 20 mm. So, to solve for the area remaining, the y, area remaining that we need to get Para makompleto natin yung half area, it's 500 and then divide by the thickness of the web which is 20 mm. Kaya nakuha natin yung 25. Okay? Yan. O, solve for y ka na. Pwede na siya. No? Shift solve for y na lang. Basta kalahati ng area. No? Kalahati ng area. Pwede ka rin dito sa baba. You can actually set it by considering the reference axis dito sa lower part ng ating web, no? 45 plus 20h. That's right. That's right. That's right. 45 equals di ay. Tama na, no? That's faster because makukuha mo yung 225 dyan, no? So, yung remaining length dito, 250 minus 225, 25. Okay? So, thanks guys, no, for helping sa natin, clarification. Okay na Tane? Are we good with this? This is just additional, no? Additional lang to na topic for discussion natin kasi pwede din naman na bigyan tayo ng medyo complicated na result, no? I mean, complicated na shape. Not necessarily complicated na hindi natin siya masolve, pero complicated in such a way na hindi siya direct formula. Hindi siya BH squared over 4. No? Hindi siya ano nga yan sa triangular BH squared over 6 ba? No? Ata. So, hindi siya ganon. So, we need to know the basic principle. Para kahit anong shape pa yan, masolve natin. Okay? Sir, pwede ni mode 3 to pareha sa pagkuha sa moment of inertia nga location of centroid. Moment of inertia nga location of centroid. Yes, I think you can. I think it can be done. Linley, no? Si Linley may tanong sa Padlet. Pwede ba daw siya ma-mode 3-2? Pwede siya ma-mode 3-2 and solve for y, barred y, or barred x, no? Pwede. I think it could be done, no? Turn on frequency lang yapon dana, no, Lin? I think it could be done. Turn on frequency. That's why. From the top, for example, that is 20 divided by 2. Tapos yung area natin dyan, 20 times 200. And then for the bottom, that's 20 plus 250 over 2 with a total area of 250 times 20. No? So, now not needed yung input sa X. And then you just go to apps, SFAR, and then barred Y. 85. Dili na din siya pwede. Hindi siya pwede, no? Kasi weighted average siya. Iba na pala. This is actually, siya, no? Location of elastic neutral axis ni siya. Lid, no? So, na-confuse lang ko. So, the value that we get here is elastic neutral axis. So, iba siya, Lid, no? Iba siya kasi yung requirement natin dito is we have to get equal areas. Alright? Kasi this is supposed to be 45, no? Okay. Sige. So, let's proceed, no? So, thank you for those questions, no? And suggestions para at least na explore natin kung possible ba talaga or hindi, no? I initially thought it's possible pero it was actually for the elastic neutral axis, not the plastic neutral axis. No? Okay. Sige, so let's proceed na. I think we're done with this. Na additional discussion lang tayo for plastic neutral axis. So dito tayo ngayon sa number 41. Each of the two elastic rubber bands of the slingshot shown in the figure below has an unstretched length of 260 mm. They are pulled back to the position shown. Each rubber band has a stiffness of 80 Newton per meter. A equals 360, B equals 100. What is the pulling force? This is our given, no? Na mga dimensions sa atong problem, no? Okay, so A 360, B is 100, LU is 260, and wala, sorry. K is equal to 80 Newton per meter. Alright? So, if you're going to lay out the forces and the angles and the dimensions that are provided, it will look like this. Okay? So, the length of the stretch band, or rubber band, LS, is by Pythagorean theorem, square root of A squared plus B squared. So, that would be 373.63. The length of stretch ng ating rubber band is the stretch length minus the unstretched length na 260, no? So 373.63 minus 260 is 113.63. So the equivalent force is the stiffness times x, or the amount of stretch. So that's 18 Newton per meter times the x distance na 113 converted to meter. So, i-multiply natin yung dalawa, we have 9.09 Newton. Solving for theta, we have arctangent B over A, or arctangent 100 over 360, that would be 15.524 degrees. And we have solving for P, that is 2t cosine theta, or 2 times 9.09 cosine of 15.524 degrees. The answer is 17.517 newtons, letter C. Okay? Varinian's theorem. I think Varinian's theorem will yield the same result as yung sa calcu kanina, which is elastic neutral axis. So, iba siya. Iba siya, Enzo, no? So, Varinian's theorem is same with the one that we had in the calculator. If you would check. So, let's just stick to that principle. Ano nga yung principle doon? So, the principle that we applied there was that areas lang talaga. Locate the axis or the position of your axis such that it divides the area into two parts. Alright, sige. So, let's proceed to the next one, number 42. Na pala yung figure ko dito. Okay. So, a series of uniformly spaced hangers along a parabolic cable support the suspended girder shown. So, given L equals 60, so the total span is 60. W is 14 kilonewton per meter. The sag Y is 6 meters. What is the maximum tension in kilonewton in the cable? Okay? So, yung procedure sa pag-analyze nito, usually we just analyze a half length of the cable. No? Half length of the cable. And it would somehow look like this, no? If you're going to look at the figure here. We just adjust the location. Kasi it should be somewhere along the middle of the half length. Change ko lang siya dito, guys. Ayan. This is not correct, no? So this is now our, parang ano ba, free body diagram, no? Of this half part of our cable. No? This is the free body diagram of the half part of the cable. And we can clearly see here that this is where the three forces coincide, no? And that is the tension at the support, the horizontal ano to? Reaction at the bottom, no, most part of the cable, or lowest point or sag point of the cable, and the resultant of our uniformly distributed load acting on the entire length of the cable. Okay? So, mo ni siya diri no, makita na to. Okay. So, if you're going to look at the triangles that could be formed here, ganito yon. If you're going to form the force polygon, pag meron tayong concurrent forces. So, yung concurrent forces natin is the tension at the support, the uniformly distributed load resultant, and the horizontal force. No? So, pag iporma natin sila ng force polygon, ganito yung itsura nila. No? WL over 2, that's the resultant of the vertical load. This is H here below, and we have the tension at the support at the top. No? So, mani siya. You can form this triangle. Now, another triangle that you could form here, guys, is this one, no? This triangle over here. So, this is the triangle that would be formed by this part of our cable. So, Y, this is theta, and this horizontal length is L over 4. Balik kalahati siya ng ating total length dito. Kasi yung total length natin dito, this is L over 2. Kasi we're analyzing 1/2, no? Oh, L over 2 man siya. So, this part over here that we use for our triangle, this is now L over 4. So, pwede po din nato gamiton sa analysis. Okay? Pwede po din nato gamiton sa analysis. So, depende lang, no? Depende. So, there's no hard and fast rule as to what procedure you would want to apply as long as you will get the correct answer. So, walang problema talaga, no? Depende lang kung ano yung nakasanayan mo na procedure. You can just stick with that. No problem at all. Okay? So, let me just show you the solution if we're going to use any of these two triangles that we have here shown in our slide. Okay? So, dito tayo sa next natin na slide. So, ano daw yung maximum tension sa cable? So, maximum tension sa cable, okay, pakita natin yung given muna that 60 yung ating total span, Y is 6 meters to yung sag, tapos W is 14 kilonewton per meter. So, if you're going to solve for theta, if you're going to use this triangle over here, no? So, arc tangent siya, 6 meters yung span, yung sag, tapos 1/4 of the total length na L over na L equals 60. So, that's 0.25 L or L over 4. The angle here of this triangle is 21.801 degrees. Ito. The angle here is 21.801. Okay? So, W1, that's the, ano yan, total weight atay, ano? Okay, resultant vertical load due to the distributed load is 0.5 W times L or WL over 2. So, that is equal to 420 kilonewtons. Okay, 420 kilonewtons. So, the tension, if you use this theta over here, tension is equal to the opposite side divided by sine of theta. Kasi W1 is equal to T sine of theta. So, analyzing this triangle here, applying our trigonometric functions, you can solve for the tension. And that is 1130.905. No? So, gigamit nato ni nga theta here because these are the same theta. These are the same angles. So, you can use the given sag as well as the given span. Hindi siya total span. 1/4 lang a quarter of the span. Kasi dyan yung point kung saan nag-intersect din yung tatlong forces natin. So you could use that as well. No? Okay. Sige. So I hope nakuha ang procedure, no? By the way, we haven't checked our stats for the past 2 questions pala, no? Number 41, yung kanina sa rubber band, we have 61.62%. Okay, ito yon. Okay. Okay, so ito yun, no? Yung sa rubber band kanina. Tapos dito sa parabolic cable, ayan, 70%. So, pwede na pala itong hindi i-discuss, no? 70-80%, that's relatively good, no? Napaka ayos na stats na yan. So, main taog, ma-maintain, no? We could maintain that good statistic result. Okay? So, that's for number 42. Dito tayo sa number, if we're going to use this as well, no? Kung gagamit tayo ng triangle na to, pwede din pala ma-solve natin yung t using the Pythagorean theorem. So, yung W1 natin dito, or 0.5 WL, or WL over 2, 420 na to, no? Yung vertical force natin. Ano yung horizontal force? You can actually solve that. And you can do that by summing up moments dito sa point A. Okay? Dire ka mag-moment pa sa point A. So, this is summation of moment at A equals 0. So, H times the moment arm natin na Y is equal to WL over 2. Yung W1, which is WL over 2, mamani W1 din. W1 times L over 4. So, L over 4 yung kanyang moment arm. So, W1 times L over 4 divided by Y is equal to 1050. Okay? And then from that, you can also apply Pythagorean theorem to get the maximum tension in the cable, which is 1130.885. Okay? So you can do that. Once again, many different ways. No hard and fast rule on which way to apply. As long as you arrive at the correct answer. The difference in the length of the solution is very minimal. No? Pare-pareha lang yung ating steps na kailangan nating kunin. And this solution also solves for H kasi sometimes pag may mga situation tayo involving cables, there could also be a possibility that the minimum tension, which is H, or the horizontal force applied in a cable would also be asked. No, hahanapin yan siya. Okay, so this would also come in handy kung alam natin yung paraan na pag-solve ng mga parabolic cables using this method. Okay? Sige. So that's for number 42. Dito tayo sa next problem. Number 43, a simply supported beam is loaded with a concentrated load of 40 kN at a point 1 meter to the right of the midspan. The beam spans 12 meters. Determine the maximum shear in the beam in kilonewtons. So, there is no figure for the beam there, but of course, we can easily interpret it and it would now look like this. Okay? Yan. So, how do we solve for the maximum shear? Basically, kunin lang natin yung maximum reaction. So, the maximum reaction here can be solved from our summation moment. Okay, summation moment lang na, no? So, kani siya, moment at right end ni siya. P times 0.5 L minus 1, so 5 meters. Divided by L, no? 40 times 5 over 12, so that's R1. 16.67 for R2, P times 0.5 L plus 1 divided by L. So that's equal to 23.33. So the maximum shear in the beam is the nearest, no? Nearest is letter B. Okay? And that would be our answer. All right. Okay. Number 44. Determine the shear strength of a 12 mm fillet weld using E70 weld electrodes for a weld length of 250 mm. So here we have our solution. This is 0.707 times thickness times the length times the allowable shear stress for the weld na 0.3 FU, so 307.969. Letter A from our choices. Tingnan natin yung stats. Sa number 43 kanina, 87% got that correctly. And for number 44, no? Sa number na to, number 44 tayo, we have 71% as well got that correct. So ito, napaka-ayos na to na mga statistics, no? Really happy to have it. Sana ma-maintain natin yung mga stats na ganito. Okay? And with as time goes by, no, and we follow the system that we had here, lalo na sa mga nag face to face pa, face to face na encounter na yung problem, tapos you have a second chance to prove that you have now understood it by taking the online exam, no? So second try na to sa pag-apply ng principle on another exam, and we can see na nag-improve talaga. So if we just maintain that, no, focus tayo sa pag-improve ng ating performance, no? Let ourselves be our own metric on a way that we compare our performance with ourselves, not with others. No, with ourselves. Okay? So, ano yan? Self-improvement talaga, no? Wala ba kayong questions for this particular na question or problem? Okay? No questions at all? Alright, sige, let's proceed, no? Proceed ta. So for our next question, determine the critical buckling load of a steel column with E equals 205 gigapascal, L equals 7.8, I equals 420 times 10 to the 6 mm to the 4th, and an effective length factor of 1.2. Okay? So, this is simply application of formulas. So, kailangan alam natin yung formula na to. Pi squared EI over KL squared. Walang magbibigay sa atin ito dun sa board, no? Let's not just assume na lahat ng formulas talaga ibibigay. There are certain formulas that we really have to know, no? Okay, such as this Euler buckling load formula. Okay, so pag i-substitute natin yung given natin dyan, yung answer natin is 9699.541 kilonewton, letter A. And for number 45, letter A also yields us a statistic of 76.94%. So that's also very good, no? From the standpoint of the value itself, no? We know na pag greater than 70 or 80%, majority na talaga, no? Yun nakakuha. Okay. So, no questions on this? Wala ra, no? Okay, so no questions. So, we will proceed with number. Wala na questions? Basta, no? Number 46, 47, and 48. Okay, so let me just tingnan natin yung stats dito. 46, 47, 48. So dito we have CDA, no? CDA. Ang stats nato is 81 yung sa number 46, 52 para sa number 47, and 59 para sa number 48. So, as we can see, may improvement sa first, pero sa second and sa third, mababa pa rin ito, no? 52 tapos 59%. Sana 60 ka, 70, above 70 talaga para we could be confident na master na ninyo yung principle nito, no? Pero pag 50, around 50%, kulang pa. Kulang. Okay? So, tingnan natin yung solution. So, yung given natin dito is a 7.2 meter high retaining wall subjected to lateral earth pressure. So, ibig sabihin, meron tayong force dito sa soil, no? That's 48 kilopascal at the top, 120 kilopascal at the base. So, analyze per meter length of wall. So, bale, pag mag-analyze tayo per meter length, magiging kilonewton per meter na lang na siya, no? Kaya ang kilopascal, that is kilonewton per meter squared. Ni-analyze tag per 1 meter, canceling isang meter. So, kilonewton per meter na lang. Per meter length. Kilonewton per meter. That's why we have it in terms of distributed load. Okay? So, sa number 46, dali na kayo, 81% got this right. Hindi na kailangan i-discuss, no? Pero i-discuss po na to. Okay? So, we could simply divide the forces into two different parts, no? Meron tayong distributed load na 48 kilonewton per meter. Meron tayong distributed load, varying load, na 70 kilonewton meter sa dulo. So, the sum of these two is 120, yung original natin dito na total width, no? Or value sa ating distributed load. So, what are we going to do here? Of course, get the first moment, no? 48 times 7.2, yung total height pala guys, 7.2. Moment arm, 7.2 over 2. Plus, para sa triangular load, 1/2 times base times height na 7.2. Moment arm from the base, 7.2 over 3. So, the answer is 1866.24 kilonewton meter. Letter C from our choices. Okay? Ayos. Alright, sige. So, let's now consider the next question. So, para sa next question, okay, para sa next question guys, we're going to review the formulas para sa cantilever deflections, no? Cantilever deflections. Okay, when we had our review discussion para sa deflections by formula, pinakita natin yung iba't ibang mga formulas, no? And those formulas that we need to familiarize kasi paulit-ulit yan na lumalabas sa board exam. And sometimes, walang formula yung ibibigay. So, yung first formula here that we shown para to sa simply supported beam. Although this is not the type of beam that we are analyzing right now, however, make sure that familiar tayo sa formula nito. PL cube over 48 EI, no? Last week, I think, or last week, no? Na-discuss natin to. Meron tayong problem na we're going to analyze kung ano yung value ng load in order to not to exceed a maximum deflection set by the problem. And walang formula na binigay doon. So, we simply just need to know this. PL cube over 48 EI. Yung slope at the supports nito, that's PL squared over 16 EI. Okay? So, this is some of the formulas, no? Yan. Tapos, pag distributed load, we might as well be familiar with eto, no? Yan. Yung formula para sa deflection at the midspan ata yan. deflection at the midspan, no? So, we have to familiarize that as well. Okay? Kasi, paulit-ulit to na lumalabas sa board exam. Mga common loading situations such as this. So, please be aware, please be familiar with these formulas. No? Kasali na din yung slope ha. So, ito 5WL to the 4th over 384 EI. Yung slope WL cube over 24 EI. And then, dito na tayo ngayon sa cantilever. So, this is primarily, eto, skip na natin to. Eto, cantilever beams. Because this is what is asked here dito sa problem natin ngayon. Okay? So, for cantilever beams, we have formulas that we should memorize as well. So, that would be, eto, PL cube over 3EI. So, ito yung ating deflection sa free end pag yung load natin is a concentrated load acting at the free end of our beam. Okay? Expected yan na alam natin yung formula for that particular loading condition. Okay? So, yung slope natin doon, PL squared over 2EI. Alright? So, I hope, no? We could spend some time para ma-master nato ang lahat ng formulas. Lahat ng formulas that would be needed na kailangang alam natin. Okay? Sige, next. Ito, cantilever formulas. We also use this sa solution natin dito. So, ito yun sila, no? Cantilever beam formulas for distributed load all throughout the entire length. Okay, so ito yun siya. So, formula is WL to the 4th over 8EI, WL cube over 6EI for the slope. Kailangan memoryado to, ha? Alright. Okay. And lastly, the formulas for deflection, pag ito yung loading, kailangan alam din natin ito, yung mga formula na to, deflection and slope. So, pag meron tayong distributed load, maximum value na sa dulo, WL to the 4th over 30 EI. Please, no? Kailangan alam natin to. WL cube over 24 EI, ML squared over 2 EI, ML over EI. Okay? So, sa board exam, we cannot avoid memorizing formulas. Talagang meron yan. No? Talagang meron yan. Okay? Lalo na sa mga nag-aim na mag-top, no? Kasi sa mga mag-aim na mag-top, we want to solve problems faster para may time pa tayo makafocus sa mga problem na medyo confusing, hindi natin nakuha. So, time saver talaga yung mga formulas. Alam natin na may mga nag-a-advertise na hindi na kailangan mag-memorize ng formulas, ganun. Well, pwede naman siya ma-derive. Pero magde-derive ka pa ba doon sa actual board exam? Maubos yung oras mo, no? Okay. So, kung alam mo yung formulas, that's a really big advantage for you. Alright? Paano, sir, formula pag yung triangular load, yung maximum nasa free end? Ano lang, isabay mo yung ganito and the previous one. Bali, ano siya? Superposition. No? Pwede din na siya integral. You can actually use integral for that. Pero hindi natin ma-discuss for that for now. No. Meron tayo. Na-discuss natin yan sa review that you can integrate. Pero the simplest way, kung ganito yung type of beam natin, no? That's just equal to, sorry, let me just redraw. So that's just equal to ganito, going down. Diba, going down ni siya? Plus going up. So, alam natin yung formula nito. Alam natin yung formula nito. So, you can just apply superposition. Okay? Sige. So, balikan natin yung problem. Balikan natin yung problem. So, yan yung sagot ko dyan, no? John Joshua sa Padlet. Oh, may tanong dito. Good morning, sir. Okay ra ba sa weekly pre-board problems na lang mi mag-rely? Ug mga problems na i-solve, sir? Dili na mi mag-CRF? Depende talaga sa time nyo, no? Depende talaga sa time nyo. Pag mag-extra time pa kayo, then I would really advise or I would really recommend na you spend it on solving CRF4 and so on and so forth, no? Okay? I don't think na by solving and resolving your modules, maubos yung time nyo for the entire day. I don't think. I think you still have additional time, no, that you could use for solving other problems. Kasi when I was preparing for the board exam, ganun din yun. Of course, focus ako sa solve ko muna yung binigay na handout, solve ko lahat, solve natin lahat. Okay? Review ko yung mga namali ko. And then after that, I still have around 3 or 4 hours to work on other problems, no? So, that's when I open the book and solve problems again. Diba? I know it's different from one student to another, lalo na pag medyo nag-struggle kayo na intindihin yung principle. So, it would take more time for you to understand, no? Pero pag meron pang extra time, I would really recommend that you continue solving your CRF books, no? Kasi mga passboard yan. Although sa ating mga refresher modules, nagsosolve din tayo ng mga passboard. This is passboard, the one that we're solving right now, situation 12. Okay? So, that's for your question, Rika, no? Diyan sa Facebook comment natin. Alright. So, ano yung nangyari dito sa number 47? To prevent excessive deflection at the free end, the wall is braced at the top. What force is required at the prop end of the wall to limit the deflection to 25? Nilagyan siya ng prop support pero hindi siya flush at the beam level, no? O ibig sabihin hindi siya magkadikit talaga sa beam ba. It allows for a certain deflection of 25 mm at the free end. Well, of course, this is also a prop support. So, meron siyang reaction dyan. Tawagin natin yung reaction dyan na P, unknown. Yan yung question natin dito. What would be the force there to limit the deflection to 25 mm? So, yung loadings natin, take note. Ano yung loadings natin? Triangular loading and uniformly distributed load. Tingnan mo yung mga formulas na ginamit ko. Okay. WL to the 4th over 30 EI. That's for this load. 72 kilonewton per meter. WL to the 4th over 8 EI, that's for the uniformly distributed load. Yung 48 kilonewton per meter. Yung PL cube over 3 EI, that's for the reaction at the support. Equals 25 mm siya. Kasi meron tayo ditong gap or meron tayong limit sa deflection at 25 mm. Okay? Ganyan. I-substitute natin lahat. Ganito siya, no? 72 yung ating W3. Yung W2 natin 48. Yung ating P is unknown. Doon sa kabilang side 25. Yung EI natin common. So pwede ko ilagay as a common denominator which I could transfer to the other side and then shift solve for P. Okay? Yung units na ginamit ko is Newton per mm. Kasi yung kilonewton meter, equivalent din yan siya sa Newton per mm if you're going to convert. Okay, so yung length natin dito is in terms of mm. Shift solve for P, you have 97045.71 newtons or 97.05 kilonewtons, letter D. Okay? Sige. Please trace the solution there and make sure you understand. Siguro from those who have taken the face-to-face or attended a face-to-face class, I also included this a discussion. Alright, sige. So, if you're done, dito tayo sa number 48. When the wall is propped at the free end, what is the resulting moment at the base of the wall? So, propped siya sa free end. So, yung kaibahan nito, yung kanina may allowed deflection tayo na 70 at 25 mm ata, no? Pero dito, we closed that, no? In such a way that the support really is applied, no? At the cantilever retaining wall, no? So, it doesn't allow any deflection at the free end. So, yung change natin sa formula is this right-hand side na instead of placing 25 mm here, I set it as 0. Okay? I set that as 0. So, pag shift solve natin, yung common denominator nga natin dito, magiging 0 na yan. Magiging, wala na yan. Cancel out na yan. No? Kasi, pwede natin yan ilagay sa right side. EI will simply cancel out. So, P is 181.44 kilonewton. Pag i-shift solve na. Now, the question is moment, no? At the base of the wall. Moment at the base of the wall. So, how do you solve for that? The moment at the base of the wall is M1 minus P times 7.2. Merong P tayo, no? Ito yung P natin, guys. Ito yung reaction. Lagyan ko na lang ng label dito sa taas. This is our P force. Okay? So, P times 7.2, that's the total height of our wall. 559.87. Kung naalala ninyo, nag-solve tayo ng moment due to these loads. Yung first question natin sa situation. Which was number 47, 46, no? So, the answer there was 1866.24. Subtract natin ng moment caused by the concentrated load and you will have 559.87. Wait, 559 ba? 559 na siya. 181 times 7. Okay. Alright. You have questions on this, guys? Please let me know, no? Alright. Sige, so number 49, no? Number 49, 50, and 51. So this is now situation number 13 sa online module natin. Alright? So, wooden planks 400 mm wide and 75 mm thick are used as temporary cantilever retaining wall. The wall is 2.8 meters high and assumed fixed at the base. The unit weight of soil is 17.8 kilonewton per cubic meter with Ka equals 1/3. Allowable bending and shearing stresses of wood plank are 10.6 megapascal and 0.8 megapascal respectively. So here are our questions, no? Number 49, calculate the maximum bending stress in the plank in megapascal. Calculate the maximum shearing stress in the plank. And calculate the required plank thickness to avoid failure of the wall. So wala tayong figure for this problem. However, if we read the question properly, we could somehow visualize, no? Or try to imagine what the situation is like, no, for the structure that is being described. So we have a cantilever retaining wall made up of these wooden planks. Okay? So ito yun siya. And because we have soil being retained by the wall, we expect to have soil pressures and soil forces, no? Lateral earth loads coming from the soil that is being retained. Okay? And the resulting stress diagram of this is triangular, such as what is shown here. And we have the force applied at the distance h over 3 from the base of our retaining wall. Okay? So let's now consider number 49 and 50. So for number 49, we have, these are the given guys, no? So meron tayong width, depth, we have the length, no? And unit weight of soil, and Ka as well. So our Fa, or the acting force, is Ka gamma S L over 2. This is pressure at centroid times area, no? So unsa may pressure at centroid? Dito yan sa gitna. No? So if we're going to consider the centroid as this part, yung pressure natin dyan is Ka gamma S, kalahati ng buong length. No, buong length ng wall. Okay? So ito yung PCG natin. Yung area is the length times the width. L times B. Okay? So you're probably familiar with this formula. 1/2 Ka gamma S L squared B, no? Oh. This is also the direct formula for this particular case. No? 1/2 Ka gamma S L squared times B. Now, just take note, no? Kasi may times din tayo sa geotech na yung B na ginamit natin is 1 meter width. Na 1 meter width. Pero dito, yung ginamit natin is the 400 mm width of our wooden plank. So, make sure you use that here. So, when you substitute the values, 1/2 Ka gamma L squared and B, we have 9.303 kilonewton. That is our Fa. Unsa gani ang Ka, sir? Ka is active soil pressure coefficient ba? Can you please confirm? Active na siya. Ang Kp passive. Okay? 1 minus sine phi ata yan over 1 plus sine phi. Na? Muna siya ang kuan niya. Phi is the angle of friction for the angle of internal friction for the soil. The geotech, no? Okay. Alright, so our MA, moment at A, or the maximum moment in the bending, in the plank, no, is Fa times L over 3. So, yung ating Fa, di ba, hindi yan nag-act sa CG. Saan yan nag-act? CP, center of pressure, di ba? Yung center of pressure natin for triangular, nasa distance L over 3. Okay? 2.8 over 3. So, our MA is 8.683 kilonewton meter. Active earth pressure, 1 minus sine theta over 1 plus sine. Oh, tama. Taga-geotech din, no? Pero it's good that you recall that, no? Madali nag-shift yung brain niyo ba? Pa, mo man yung formula, no? Merong formula din yan, using the tangent squared, guys, no? Ang tangent squared formula, ano siya, ganito siya? Tangent squared formula, no? So, going back to our solution, we also have the shearing stress equal to FA, that's 9.303. And then we have FB 6M over BD squared. Maximum bending stress is what we're looking for here. Ayan. So, substitute natin 6 times the moment, which is 8.683 pala, sorry. 8.683 times 10 to the 6 Newton mm over 400 times d squared. So, 23.16 megapascal. Letter B. Ayan. Stats check tayo guys, no? Check natin yung stats. Number 49. We have 73% got this correctly. Wow. Amazing. That's good. Maayos ba yung discussion natin sa F2F nito? Any comments sa mga F2F students natin dito? Ano yung pwede nating ma-improve sa face-to-face natin na discussion? Please let me know para makagawa tayo ng mga adjustments, no? Ayan. Medyo mabilis yung face-to-face natin na discussion nito kasi inubos natin lahat in just 1 hour 45. Dito sa online, parang medyo free tayo, no? Kasi may extra time tayo. Mahaba yung klase natin. And you can ask your questions. Okay? So, pag may mga comments kayo sa discussion natin dun sa face-to-face, please let me know, ha? Para magawa natin ng paraan. But for this week, wala akong face-to-face class, no? Balik ako sa face-to-face by next week na. Ayan. Meron kasi kaming important na activity for the week, no? Alright. Sige, so okay na din. Number 49, no? 73%, that's already very good results. So let's have number 50. Calculate the maximum shearing stress in the plank in megapascal. Calculate the maximum shearing stress in megapascal. So, yung maximum shearing stress natin, dito yon, no? 9.303 kilonewton. So, what we're going to do is get shearing stress. Ang shearing stress formula is 3V over 2BD. 3V over 2BD. So, that will now give us 0.465 megapascal. Letter C. Dalira, no? So, yung statistics natin, yung pinakita natin kanina, for number 50, 72% got that correctly. Napakaganda ng result na yan, no? Depende talaga yan sa inyo, no? Ayan. Ayos. O, may Sir, pwede po pa-explain ulit bakit yung 475 ang kinonsider para sa BD? Wooden plank. Wooden plank na siya dyan, no? Wooden plank dimensions. The wooden plank dimensions are 400 mm wide. So, yun yung B natin. Yung D natin is the 75 mm thick. Okay? Tapos, yung formula natin is the formula for the rectangular section, no? Kasi rectangular naman siya. Rectangular man na. 400 by 75. Tama ba? Okay. Sige, please ask questions, no? Taas kitag oras diri guys, no? Mahaba talaga yung time natin dito. So, pag meron kayong mga questions dyan, I would appreciate, no? Para di kayo under time. Hindi kayo mag-under time. Ah, okay. So, please let me know lang, no? Still have enough time to post your questions there. Sir, ngano na 3 hubs? Formula yan siya, Renz, ha? Formula. 3V over 2A kasi yan basta rectangular. 3B over 2BB. Formula to. Formula. Shearing stress, rectangular section. So, galing yan siya sa VQ over IB. Galing yan sa VQ over IB. Okay? So, hindi na lang natin ipapakita. Pero that's what it is. Sir, ano formula ng shearing stress sa triangle? Yan. Triangle Wisam. Ay, let me double check on that, no? Pero yung naalala ko ba sa triangle, 3B over A? No? 3B over A siya. Okay? Triangle. Parang 3B over A yung triangle. I mean, bakit po sir hindi yung 2.8 meters para sa D? Hindi yung 2.8 meters. Parang ano lang yan kasi, dyan ba? Parang beam lang, di ba? Parang beam. Beam na may cross-section. Tapos may mga loads ka dyan. Di ba? Oo. So, yung cross-section for the analysis of stresses, yung cross-section yung gagamitin mo. Hindi kasali yung length or yung span. No? VQ over IB would refer to the cross-section. Okay? Magagamit mo yung L sa pagkuha ng maximum moment. Pero sa pagkuha ng stresses, you have to use the cross-section. Okay? So, inana man na siya. Vertical lang siya. Dili lang siya horizontal. Okay? It's vertical. Vertical lang siya. Ito yung mga forces mo dyan. It will bend. It will bend on its major axis. Okay? Alright. Wala na kayong mga tanong dyan? So, that's good, no? Okay ra mag-ask og stupid question. Stupid question. Okay ra, no? Wala problema na. So, really try our best to accommodate any question. Kahit na sometimes medyo ano din kami. Pero at least, no, pag natanong niyo talaga, at least we could correct your misunderstanding ba of the concept, no? Which would be really critical. Alright? So, okay na to? So, wooden planks, among gihapon ni siya given, no? Number 51. Calculate the required plank thickness to avoid failure of wall. No? Calculate the required plank thickness to avoid failure of wall. So, we have here the given allowable bending stress and shearing stress is 10.6 megapascal and 0.8 megapascal respectively. So, D1 square root 6m over, from the formula na to, no? So, we rearrange the formula, guys. We rearrange the formula. Kasi we're now solving for the required thickness. So, repeat ko lang yung formula. For bending stress, formula is 6m over BD squared. For shearing stress, 3V over 2BD. Now, these formulas are for rectangular sections, no? I repeat, this is for rectangular sections. our cross-section here is clearly rectangular, no? Having a width and having a thickness. So we could apply these formulas. Okay? So we rearranged kasi yung hinahanap dito, depth or thickness. So binigyan tayo ng allowable stresses. So changing our formula, rearranging the formula to solve for the depth, we could have 43.61 and 110. So yung mas malaki sa dalawa, yung pipilian kasi nagde-design tayo. Alright? So the answer is 110.8. Yung stats natin dyan, number 5170.3 megapascal. Ayos? Okay? So wala na kayong question dyan? Paro na no? Number 51. So meron tayong next question pa before we take our break. Tingnan natin. Mag-next question tayo. Circular ba yung 4/3, sir? Yes, 4/3 is circular cross-section. No, circular cross-section. Sige. Alright, sige. So let's have, we'll be jumping over to a different question. Dili lang ako na isunod, no? Because I want to solve this one question here na after the break. So I'll have this question first. So this is your number 64, 65, and 66. So frame ACGE ito, no? Is on a hinge support at A and E to resist the cable pull at T. The frame is braced at B and F. Alright? So we're going to solve for number 64, 65, and 66. 64, 65, and 66. So kung mapapansin nyo dito, ang laki ng stats natin dyan, 83%, 81, tsaka 79, no? So napaka-easy na lang pala nito para sa inyo. Okay? So, tingnan natin yung solution dyan for that particular problem. So, we have, ito yung figure pala natin, no? Yan. So, we're going to get the angles. The angle here for our force is 45 degrees. So, let me just place it here. Okay? The reaction at D equals the force in BD. Now, so if you want to solve for the reaction at D, you might as well just get the summation of moment. Summation of moment na ka, no? To get FBD. And RD is now equal to FBD. Okay? So once again, the principle here, pag gusto mong makuha yung reaction dito sa baba, no? The reaction will just be equal to the member force. Yung resultant reaction dito, RD, will be equal to FBD. So, solving for FBD will give us that reaction. Okay? Yan ang simple ang principle na to. Alright? Let's proceed. Number 65, no? Dito tayo sa number 65. Compute the stress in the brace BD which has an outside diameter of 80 and 6 mm thick. So for that, we just solve for the total area. Sir, morning. Nganong wa ka nag-resultant sa X and Y, anak? Okay. Explain nato, no? The resultant of Rx and Ry here, hyacinth, no? Is actually equal to Rd. Bali, at D, ano yung point D? This is your member force. Member force FBD. Actually, meron tayong dalawang reactions, no? Components niya, RDX and RDY. So, these two is equal to RD. And this is equal to FBD. No? Diretso na siya. You don't need to go for RDX and RDY. You don't need to do that anymore. No? Kaya mo naman na siya. Analysis at point D. Analysis at point D na siya. Okay? So the resultant there should be equal to FBD. For equilibrium. Resultant of RDX and RDY na. Okay? 45 degrees pa niya siya. It's also 45 degrees. Alright? So, ganun lang, no? Wala kasing ibang force acting at D aside sa FBD. So, they have to be equal. Collinear and equal siya, no? Yung resultant ng reaction and the force in D. Tapos yung analysis pala natin dito is considering vertical member AC lang. Point A, this is point B, this is point C. Okay, diha ang atong force, FBD. So you don't need to analyze the entire frame, just the vertical member ABC, 1 meter ito, 3 meters. Ganun lang, no? Not so, ayaw lang i-complicate. Okay? Okay na ayasin? Alright, sige. Number 65, compute the stress. Ito na yung sabi ko kanina. Just get the area. Napakadali lang, no? Get the area. Pi over 4 outside diameter squared minus inside diameter squared. Saan ka po nag-moment dyan, sir? Moment at A tayo doon kanina. Moment at A and Sham. Yung kanina ba? This is moment at A. Dito tayo nag-moment, oh. Ay, C din yung nakabutang. Sorry ha. Moment at A ni siya, guys. That's moment at A. FBD sine 45 times 1. Okay? A is 1 actually. TL. So, meron tayong 20 kilonewtons. 20 ba? Or 40? 30 pala, 30. 30 kilonewtons times 4 meters. Okay? So, that is summation moment at A. Yeah, analyze one vertical member. Okay? Analyze one vertical member lang. C kasi nakalagay. Yes, that's correct, no? I have to edit that pala. Hindi yan C. That's supposed to be A. Sige lang, no? I'll just make the correction later. So, okay na din, 65. Stress is basically just force over area, no? So, we have the force sa first question, 169706 Newton. Compute lang natin yung area. Pi over 4 outside diameter squared minus inside diameter squared. Alright? Sige. Next question, number 66. 1 to 1.6 na yung answer, no? Letter A. Number 66, if brace BD consists of two flat bars bolted to post AC at B using 20 mm diameter bolt, what is the average shear stress in the bolt? Ayan. So, tingnan natin yung solution for that. Teka lang guys ha. Ayan. So, FBD over pi over 4 d squared times 2, no? Times 2 kasi naka-double shear ito. Naka-double shear yan siya. Okay? Double shear. So, pag sinabing double shear, parang ganito yung nangyari dyan, no? Yan, no? Ay, bali din ni siya. Ang kuan din ni, ang B ang doble. Sorry guys ha. Kamali ako ng kuha ng sample picture pala. It should be FBD having the two flat bars. Drawing na lang ako. Okay. I-drawing mo ko ni sa face-to-face. I tried to search for an online picture pero wala ako makuha. So, basically, meron tayong member dito na dalawang member sila. Doon sa kabila din. Basically, parang ganun siya, no? So, this is our member force BD. Dalawa siya, no? Near side, far side, connecting onto our vertical post. Dalawa yan. So, far side, near side lang, no? Doon sa kabilang side siya, sa far side. Ito yung sa near side. Okay? So, try to imagine na lang. So, double shear siya, yung ating diameter. Ating bolt. So, that would be letter C, no? For number 66. Ayan. So, let's have our break, everyone. Let's have our break and please resume 10:30. Meron tayong 3 more situations to go. I think we'll finish early, no? Pag matapos natin yan ng maaga. You can entertain more questions for our discussion, no? Para sa remaining hour natin. Let's have our break, everyone. Okay, so let's continue, guys, no? Welcome back. So, we have 3 more situations to go. So, tingnan natin yung situation number 14. Ayan, situation number 14. So, situation number 14, we will be considering numbers 52, 53, and 54. So, dito sa stats natin, kung scroll up lang natin ito, we have the following stats, no? 67%, 82.29, tapos 43.73%. Ayan. So, medyo konti lang yung nakakuha ng third question dyan, no? Which is based on the block shear strength of the double angle. Alright, so let's now look at the problem. So yung problem natin, 90 by 90 by 8 bolted to a 12 mm thick gusset plate, no? Yung mga spacing natin dyan, 50, 40, 45, 50. Tapos yung mga data natin remains the same. Okay? I think parang may ano tayo dito. FU here should only be 400 ata, no? I think that's one typo here that, well, it doesn't really affect naman the solution, no? We still get the same result. Parang FU ata, no? FU. Let me just put that here, guys. Sorry, no? That should be 400 megapascal. Siguro may gumamit ng ano ba, 480, kaya hindi talaga siya makuha, no? I think that could be the reason why only few got the third question correctly. Anyway, yun yung problem dyan, no? Okay, so allowable tensile stress on the gross area is 0.6 Fy, tensile strength on the net area 0.5 Fu, allowable shearing stress is 0.3 Fu. So, what is the capacity based on the bolt capacity in shear, based on bolt bearing capacity, and based on the block shear strength of the double angle? Ito yung figure natin, no? So, let's consider now the first question. Based on the bolt capacity in shear. So, tingnan natin. So, we have here a double angle connection. Double angle connection. So, ito yung double angle connection. If we're going to view it section view. Meron tayong gusset plate sa gitna. Tapos, we have the two angles here on both sides. So, ibig sabihin nito, yung bolts natin are in double shear. Okay? The bolts are in double shear. Ito yun, no? So, yung solution natin, allowable bolt shear stress times pi over 4d squared times 2 times 3. Times 2, double shear, times 3 because there are 3 bolts in this connection. Okay? So, pag i-substitute natin yung data, we will arrive at letter D for our answer for number 52. And that is 103.8 megapascal. Okay? So, okay na, no? Bolt capacity in shear. I hope that makes sense. Times 2 times 3 tayo dyan by virtue of double shear and the number of bolts. Alright, so we have the answer 103.8. Let's now move on to the next question. So, we're going to compute for the capacity based on the bolt bearing capacity. So, yung bolt bearing capacity natin is this one. So, that is allowable bolt bearing stress times diameter times thickness of the gusset times 3 bolts. Okay? FP, diameter times thickness of the gusset times 3 bolts. So, if we substitute everything, that's 311. FP is given, no? Allowable bearing stress is given in the problem, and that is 480 megapascal. we are going to use the thickness of the gusset here kasi mas critical siya, no? As what I have explained sa online class, if you still recall, yung thickness ng angle natin is 8 on both sides. While the one in the middle is 12 mm. So, yung angles natin, 8 mm, 8 mm, that's a total of 16, no? Kung i-consider natin yung angles, the equivalent thickness of the angle would be 16, 8 mm per angle. Okay? Per side of the gusset. Meanwhile, for the gusset itself, it's 12 mm. Ito yung thinner member dito sa connection. So, the thinner member would govern. Siya ang mag-govern because it will give us the least capacity when it comes to the ball bearing. So that is the reason why we are considering that para sa ball bearing capacity na. Okay? Alright, so dun tayo sa next question, number 54, based on the block shear strength of the double angle. Kung wala kayong tanong dyan, let's proceed. So, for the double angle, no? Ito yung ating block shear. Ito yung ating block shear. No? So, anong makikita natin dyan? Ito yan, no? So, this is the direction of the force, by the way. Ito yung direction of force. So, dito, makita din natin yung 3D view for the holes, no? Okay. So, tingnan natin yung solution for this particular pattern of block shear failure. So, that is tension area. Kunin natin yung tension area. For the shear area, kunin din natin yung shear area. Okay. So, saan ba dito yung tension tsaka yung shear area? So, tingnan natin yung ating figure. So, this is the direction of force, no? So, all areas that would be parallel to the direction of force, this is our shear areas. While the areas that are perpendicular to the direction of force, these are normal areas or tension areas. Okay? Yan. And don't forget na i-multiply natin siya with their thickness. As you can see here, no? Multiply na siya with the thickness. And take note, this is net areas. Net areas ito, guys. So, pag sinabing net areas, don't forget to subtract the area, the diameters of the holes that the crack passes through. No? Yan siya, no? So, for the shear, 1, 2.5 yan. S2 plus S3 plus S4, S2 plus S3 plus S4, minus 2.5. 1, 2.5. Okay? Diameter of the hole times thickness. So, 680 mm. 8 mm, saan natin to nakuha yung 8 mm? How did we know that that is the thickness of our angle? So, yung description natin is 90 by 90 by 8 na angle. Diba? So, yung 8 mm dito refers to the thickness of our angle. Okay? So, that is why we have the 8 mm here. 8 mm. Okay? So, what about for for the tension area? So, yung tension area natin dito is S1 minus 0.5 dH. So, yung S1 0.5 DH, no? As you can see there, it's one half of the total diameter that will be passed through by the crack, no? Hindi siyang apart. So S1 minus 0.5 DH, don't forget to multiply with the thickness of the angle to give us 320 mm squared. Okay? And then, after that, to compute for the capacity, here's what we'll get. We have 0.3 FU AV. So yung 0.3 FU natin, this is allowable shear stress times the shear area. 0.5 FU is the allowable tension stress times the tension area. Alright? The times 2 here is for the double angle connection. Double angle connection. Okay? So, if we substitute, it would look like this, guys, no? 0.3 FU. Siguro dito nagkamali yung ilan, no? Kasi yung ginamit nila yung 480, which is actually, yun naman yung nasa, nasa question. Actually, yung FU dyan is just 400, no? So, sorry. So, 0.3 FU yan, tapos 0.5 FU ito. Okay? And then times 2 because of double angle, 291,200 Newton or 291.2 kilo Newton. So may tanong si Kent Jomar dito, no? Sir, di na nato i-consider ang double shear pag block shear? Hindi double shear yung tawag kasi wala tayong dito bolt shear. So times 2 pa rin tayo because of the double angle. Kasi dalawang angles tayo, no? Dalawang angles. The near side and then the far side, they will simultaneously undergo block shear failure. Therefore, we have the times 2 over here. So I hope that's clear, no? Pati ata, sir, sa CE Rep 480 din yung nakalagay. Kung hindi ako nagkakamali. I see. Kasi, we actually just took this from the CE Ref questions, no? So, siguro, that was a typo there that was carried over in this problem that we gave. Okay? So, 400 na siya. Kaya nga yung 1.2 FU natin is 480. No? 1.2 FU is 480. Kasi 1.2 times 400 is 480. Okay? So, please take note of that na lang, no? For this particular question. I think that was a typo on our part. No, we haven't double-checked it properly. Pero siguro sa mga nag-attend ng F2F, nakuha nila to kasi 400 yung ginamit namin doon sa solution. The FU was 400. Okay? Sige. So, do you still have questions on this? No? I think that explains the low percentage here, no? 43%, no? That explains the 43% of our result. All right. So if you're done with that, there's also a point that I included no sa discussion namin sa face-to-face, which I would like to share as well with those of you who are attending our online class, no? Okay, so I'll just move it a little bit here to the left. Yan. So I will share a particular point which I emphasized, no? And that is why, this is the reason why we're considering this pattern of block shear failure only, no? So, bale, ganito talaga yung failure natin, no?
So, hindi siya to the other side. Hindi siya to the other side. And the reason for that, no? Kasi yung other side natin, this is an outstanding leg. So, yung failure natin that we considered here is this one, no? This failure. Okay. So, hindi siya dadaan doon sa kabilang side and up the entire outstanding leg. This is not practical for the crack, no? So, hindi siya dadaan dito sa kabilang side. Kasi, pag dadaan siya, kailangan niyang i-crack yung buong outstanding leg. Okay? Kailangan niya tong i-crack para magiging separate member siya. 'Di ba? So, pag kailangan niyang i-crack, napakahaba nito, napakalaking area niyan. So, malaki din yung capacity. Alright? So, ganun siya. Okay? So, that's the reason. And, there's also another possibility, no? Pag mag-crack tayo dyan sa kabilang side, and then, we pass through this length going back, no? Pwede din siya actually, pero once again, the same principle applies. That will become a longer crack, no? That will become a longer crack compared with this. So pag din na crack, it would be shorter if you will just crack on this side, no? Rather than going on that side and then going all the way back. Okay? So that makes sense. Perhaps some are wondering, why is it na yung block shear failure natin dito? Isa lang yung pattern. No? Kasi dun sa plate, pag naalala ninyo, we could have multiple patterns. No? So dito, pag single, lang siya, single column or single row of bolts lang, you only have one pattern for failure for block shear, especially for angles. Magkaka-multiple patterns lang tayo pag yung ating angle will have more than one column. Kani siya, pwede naman ni Ana, no? So, multiple na siya na patterns. You can actually check that. You can actually check this. So, I think 2 or 3 patterns pa na siya, no? That you could probably check. So, that would now be like that, no? Okay? So, pag singular pattern, singular column lang, so we don't need to worry ourselves too much. Isa lang yung shear failure pattern. Alright? Just an additional point to consider lang. So, let's now consider the next, no? Situation number 15. Ayan. So, a W12 by 28 is used as a crane runway girder on a simple span of 7.2 meters. The crane wheel imparts a vertical load of P equals 70 kN and a lateral load of H equals 4 kN. A standard 420 Newton per meter rail will be used. Use A36 steel, and here are the allowable stresses and properties of the section. So number 55. Which of the following gives the maximum bending stress about the x-axis of the girder? And which of the following gives the maximum bending stress about the y-axis of the girder? And compute the maximum value of the interaction equation. Okay? So for our problem here, let's try to research ano yung crane runway girder. No? Kasi mabuti din na ma-imagine natin or maintindihan natin bakit merong tayong crane runway girder, ano yung crane wheel, ano yung rail, di ba? Okay, so ito, I changed the picture that I showed sa face-to-face, no? Kasi I found a better way, no? So ito yung crane runway assembly, napaka-complicated siya, no? Yes. So this is movable. Ito, this is movable. So it has a block there, a hook block. So pwede nimong i-attach ang imong weight and then transport it to another place along this length. So perhaps and this is placed on a certain construction area. Pwede, no? Pwede, certain construction area. So we have a railway crane, and it could transport, no? It could transport materials from one location in the construction area to another. You could also have this in factories, no? In assembly plants for automobiles or for ships, no? Pwede. So instead of manually carrying the load here by certain people or laborers from one place to another, we could do it safely and quickly with the use of this one. So this trolley frame will move back and forth, no? Para din siyang supported as well by a bridge girder. And this is the runway beam or runway girder, no? Ito, runway girder. Okay? So this is having wheels, no? That are attached to the runway rail. Ito yung runway rail. And this would move back and forth while the trolley frame will move back and forth perpendicular to the runway beam. Okay? So yung wheel na to, yan yung mag-impart ng concentrated load dito sa runway beam or runway girder. Ito yung wheel, no? Bridge drive wheel ito. Tapos kung napapansin nyo, meron tayong runway rail. So yung runway rail, parang additional plate siya or element siya na dinagdag sa taas, no? So that the end track, no? Or this motorized assembly here could attach itself into that runway rail, no? Okay? So yun yung so that we'll also understand ba what's happening o ano yung mga terms na ginamit dito. Okay? So, tingnan natin yung solution. By the way, if we're going to focus our attention on our runway girder, this is what we will see, no? So, we will have our runway girder carrying a uniform load of 1 to 40 Newton per meter. So, mamaya, mapakita natin yung reason kung paano to naging 1 to 40 Newton per meter. I'll just mention it na lang. This is actually the weight of the girder and the weight of the rail added together. So, kung balikan natin yung problem, ito yun, no? 420 plus 820. No? So, those are the uniform loads acting on our runway girder. Now, notice this, no? These are two concentrated loads acting on our girder. And these concentrated loads are imparted to the girder by the wheel. Yun yung sabi dito. The crane wheel imparts a vertical load. So, ibig sabihin, kung balikan natin yung assembly, yung mga wheels na to, they will impart that vertical and lateral load to the girder. Kaya ito, we have it here. 70 kilonewton tapos 4 kilonewton. And then I place this at the top flange because the railway crane, no? Alright, is attached most of the time on the top flange. Although meron ding mga assembly na doon sa bottom flange siya naka-attached. Okay? So yan siya, no? Alright. Now, why did I place this somewhere in the middle of our runway girder? The reason for that is concentrated loads at the midspan of a beam or a girder would generate the maximum bending moment on the girder. No? Kasi concentrated load ito, 'di ba? And it's a moving load. It's a moving load kasi yung wheels yan, 'di ba? Wheels will pass to and fro from the one point to another along the runway girder. So at the midspan, dyan siya makaka-generate ng maximum bending moment for our runway girder. Okay, so I have it here at the midspan. So balikan natin yung problem and let's now have a look at the solution. These are all given data, guys. And then I have here SX and SY, no? So SX and SY are just the section modulus taken from the properties of the section so that later on, when I do my computation for the bending stress, I will use M over S. So, gagamit ako ng moment over the section modulus of our section. So, SX is IX over C, and yung C natin is 1/2 of the depth. while SY is IY over C, where C is 0.5 of the total flange width, or 1/2 of the flange width. So this will generate these two section moduli, no? Section moduli, SX and SY. Ayan, no? So that's what we have for our first part, no? So I just had it one at a time. And then mamaya meron tayong ano. Okay, so next, no? So, yung sabi ko kanina, we're going to use this in the computation of our bending stresses. So, let's now determine our bending stresses. So, ito na yung bending stresses natin. So, for the bending stresses, this part here are just given data, no? Including the allowable stresses natin, 148 and 186. So, here, this is the total weight of the uniform load on our girder. So, bale, saan na siya? 820 plus 420, no? 820 plus 420, that's 1240 Newton per meter. Okay? For the total moment that would cause bending about the strong axis of our member, we'll have WL squared over 8 and PL over 4. So WL squared over 8, this is the maximum moment of a simple beam or simply supported beam with uniform load all throughout. While PL over 4 is the maximum moment caused by a vertical load acting at the midspan. PL over 4 ang formula. Alright? So, ayan. Pag i-substitute natin yung lahat ng data natin dito, we'll get 134.04 kilonewton meter. And if we're going to divide by our SX, you will have 105.08 megapascal. That would be letter C. Okay? So, I think we're good with that, no? Wala na tayong questions na, guys? Sige. So, we're now going to consider number 56. So, for number 56, this is now maximum bending stress about the y-axis of the girder. Okay? So, of course, these are given data. So, for our MY, that is PL over 4. So, yung PL natin dito, yung mag-provide ng minor axis bending. Ito yun, no? This is the PX. This is the P that would produce minor axis bending. No? When you push this one to the left, no? Yung member natin, it will buckle or it will bend, no? Or there will be flexural stress about the minor axis. Alright? So that's why we have PXL over 4. So substitute the data, that will now be 4 times 7.2 meters times 4 divided by 4, that is 7.2 kilonewton meter. And for our FBY, we have MY over SY over 2, which will give us 41.11 megapascal. Okay? So, yung ginamit natin dito is SY over 2. So, yung SY over 2, that is for unsymmetrical bending with loads acting not on the centroid or shear center of our section, no? Kasi yung ating element dito or yung ating section, which is a wide flange section, has the lateral or horizontal load acting on the flange. Dito yung location ng H. So, pag ganun siya, SY over 2 yung gagamitin. That's 1/2 of the section modulus for the weak axis. Okay? Yan. Pero pag dito siya nag-act sa centroid, gagamitin natin yung buong SY. No? Kasi symmetrical bending yan. Pero unsymmetrical bending with loads acting not at the shear center or at the centroid of the section, then we're going to use SY over 2. So that's how we came up with an FBY of 41.11 megapascal. Sorry. Okay? So I hope that makes sense, no? For our solution there. You have any questions so far? Wala na, no? Now, that analysis is also applied for purlins. No, kaya ang purlins good na to, they have the loads applied at the flanges as well. No, nasa sa flanges. So, that's what we're going to consider. Okay? SY over 2 siya pag yung loads nasa flanges and there is minor axis bending. Alright? Okay. Kaya na tayo guys, no? Sige. So, please let me know lang, no? Pag meron pa kayong mga tanong. Number 57 tayo, no? Compute the maximum value of the interaction equation. So, yung interaction equation natin is simply the sum of the ratio, no? Ratio siya ng actual stress to allowable stress. Ito, for the x-axis ito. And then, actual stress to allowable stress for the minor or weak axis. So, pag i-substitute natin yung mga data natin dito, you will get 0.927. So, yung FBX, maliit na FBX natin, that is for the actual stress. Dito sa denominator, yung 0.6 FY ito. 0.6 of 248, that's 148.8. Tapos yung FBY, this is the 41.11 and this is the allowable stress, no? For the weak axis, 0.75 FY. Alright? Alright, no? So, klaro na. Number 57, no? Let's have a look at the stats now, be. Number 55, 56, and 57, guys. Tingnan natin. Ayan. 55, 56, 57. So, we have 55% din for number 55 and 56. And for number 57, meron tayong 45. So, mababa, no? So, compared with the other results natin for the structural subject, I think this situation has the least na statistics, no? Okay? So, please, guys, please understood the principles that are being discussed here, no? Sayang po kayo kung magkamali tayo dito. Alright? So after this, we'll now have our last question or last situation, and that is situation number 16. Last 3 questions na for our discussion for today, no? And that would be for number 58, 59, and 60. Oh, di pa din sa pagyud. Sorry. A cylindrical water tank is 4 meters in diameter and has wall thickness of 8 mm. If the maximum tensile stress in the wall is 12 megapascal, compute the internal pressure in kilopascal. Meron pa situation 17. Oh, napaka-study eh. Kala ko last na to. If the maximum tensile stress is 5, compute the depth, and if the internal pressure is 0.5, compute the bursting force. Sige, so tingnan natin yung solution, no? I'll just show the solution here quickly. Pag sinabing maximum tensile stress in a cylindrical pressure vessel, the formula is PD over 2T. No? PD over 2T. So this is known as the tangential or circumferential or hoop stress formula. And this is the more critical of the pressures or the stresses on a cylindrical pressure vessel. Okay? So, yan siya, no? Solving for the internal pressure, we rearrange the formulas and substitute the thickness, the stress, and the diameter to get 0.048 megapascal or 48 kilopascal, letter D. For part 2, 5 megapascal yung ating sigma, no? 5 megapascal, so we have PD over 2T pa rin kasi maximum tensile stress yung binanggit sa number 59. And we're solving for the internal pressure first. 20 kilopascal yan. Pag i-substitute, labas dyan 0.02 megapascal or 20 kilopascal. Yan. And then, from that, we solve for the depth of water. So, divide by unit weight of water. We have 2.039 or 2.04 meters. That's our answer. Number 59. And number 60, no? Internal pressure is 0.5. Compute the bursting force per linear meter. That's bursting force is equal to the pressure times the diameter times 1 meter. Okay? So, bali cross-section lang siya ng cylinder, no? Eto. Cross-section na to, no? So, this is diameter and this is 1 meter. Bakit 1 meter? Because it is per linear meter. No? So, pressure times the diameter times 1 meter. 2,000 kilonewton, letter D. Tingnan natin yung choice, yung ating stats, no? Number 58, 59, and 60. 87%, nako, almost perfect na, no? And then we have 80% and 64.02%. Yes. Okay. So I think after this, we now have ito na talaga yung last, no? Ito na talaga yung last question natin. So that would be number 61, 62, 63. Excuse me. So, yung stats natin dito for situation 17, no? Number 61, 62, 63, 73%, 84%, and 80%. So, very good stats, no? If only ganito yung stats natin sa lahat, then for sure, pasado tayo sa board exam, no? For sure, pasado tayo. Alright, sige. So, tingnan natin. This is past board exam problem. No? Rigid beam AB supports load W at B. The beam is hinged at A and supported by a steel cable CD at C. The cable is 32 mm in diameter, 3 meters long. Okay, use E equals 200. L1 is 1.8, L2 is 1.2. W is 80. So, ito yung ating weight, no? Ano daw yung vertical deflection of point B? Tapos, if the allowable stress of cable CD is 135, what is the maximum value of W? And find W if the strain of cable CD is 0.003 mm per mm. So, for the vertical deflection of B, dito tayo sa solution. Ito yung ating given data. For part 1, summation moment at A tayo to get TCD. No? If we substitute moment at A, so 80 which is W, L1 plus L2, 1.8 plus 1.2 divided by 1.8, so that's 133.33 kilonewton. That's our TCD. No? And then these are the other given by the way, no? So yung length ng member natin, 3 meters. Area cross-section for CD, that's pi over 4 d squared, so that's 804.248. ECD is 200 gigapascal. So, formula for deformation. Pag meron na tayong TCD, pwede na natin gamitin yung formula for deformation. So, that is TCD times the length over AE. So, ito galing to sa axial deformation formula ng strength of materials, di ba? Okay. If we substitute the values, no? Force, the length is 3 meters, area 804.248, and E, our delta CD is 2.487 millimeters. Now, paano natin makuha yung deflection sa point B? Yung kinuha natin dito, deflection to sa CD. So, ganito yung gagawin natin. Yung deflection ng CD, guys, ito yon. Ito yung deflection ng CD. Okay? So, gusto natin makuha yung deflection at B. So, ano yung gagawin natin? We're going to apply ratio and proportion. Teka lang ha. Parang na-cover yung part ng solution ko dyan. Okay. So, this is now by ratio and proportion, pwede na nating masolve yung delta B. Ano yung ratio and proportion? Delta CD over L1, delta B over L1 plus L2. So, from ratio and proportion, guys, no, this part here, no, in our solution involves ratio and proportion, R and P. LCD over L1, LB over L1 plus L2. If we substitute our data, you can solve for delta B, and that would be 4.14 millimeters. Letter D from our choices. Okay. I hope that's good, no? So, dito tayo sa number 62. If the allowable stress of cable CD is 135 megapascal, what is the maximum value of W? So, ano yan? Kunin natin yung value ng, hindi na to applicable, inaulit lang siya, no? Sorry. So, yung part 2 natin, we are provided with delta CD, I mean sigma CD, no? Which is 135 megapascal. If you multiply natin siya with the area, then you will get TCD na 108,573.48. And we apply summation moment and then we substitute the value, you will get letter A, 65.14 kilonewtons. Okay? So letter A, no? And finally, for our last question, number 63. Find W if the strain of cable CD is 0.003 mm per mm. Okay? So, dito tayo sa part 3 na part, no? Okay, so first, yung ginawa dito, kinuha muna natin yung equivalent axial deformation. So, that is by multiplying the strain with the length of cable CD. So, that would be 9 millimeters. 9 millimeters. Now, out of this, pwede na natin makuha yung equivalent force for that by applying the axial deformation formula. Axial deformation, PL over AE, no? We rearrange to solve for the force itself. Meron tayong area, meron tayong E, meron tayong length, meron tayong deformation. So, the answer here, pag i-substitute natin lahat yung data na yon, you will get a TCD of 482.55 kilonewton. Okay? And from there, we have our weight. Ito, summation moment at A pa rin ito. So, meron tayong TCD times L1 over L1 plus L2. And we solve for the weight and we'll get substitute data, no? So, we have 289.53 newtons. 53 kilonewtons. Or 289.5 kilonewtons. So, that would be letter D. Okay, statistics natin ulit. 61 to 63, 80%. Perfect na rin, no? Huwag sanang kalimutan, no? Yung mga principles na natutunan ninyo for this discussion and the improvement that you made here so far, no? I hope you maintain that, guys. Ma-maintain ninyo kasi it is notable din naman, no? If you're going to compare the stats that we have for this set of questions before and then now, napakalaki ng increase, no? In terms of performance. So, I hope you maintain that all throughout. Okay? Ayan. Sige. So, muna to. Muna to na, no? You still have any question? Asa naman nga itong mga commenters diha, no? Marot na. Okay. So, maraming salamat din sa inyo, no? For your time and for all your efforts para sa preparation ninyo for the board exam. So, I hope you would spend the remaining time na lang, no? For preparing your lunch and for having enough rest and study then for the afternoon. Alright, so that would end our discussion for this morning. Pag may pahabol pa ng mga tanong, please post it in Padlet na lang. I will have a look at it later this evening. Same topic lang yung discussions natin this evening with this morning. Alright, sige, see you next time. Thank you so much. Bye-bye.